Welcome back, everybody. Ready for another deep dive.
Mhm.
Today we're looking at something that's more common than you might think. Trigonometry.
Yeah, trigonometry. It's one of those things.
But we're not going back to high school math class, I
Yeah,
promise.
no.
We're going to be talking about how we actually use this stuff to figure out heights and distances in real life.
Right, exactly. It's like you don't realize how much you're actually doing it all the time,
Huh.
just like in your head without even thinking about like the actual math behind it, like just figuring out how far away a car is.
Exactly.
Your brain is doing these mini trig calculations all the time.
So let's kick things off with a concept I think we all remember from school.
Sure.
Angles of elevation and depression.
Right. Yeah, those are the ones that really like help us set up those triangles that are key to solving these kinds of problems.
Right.
So, like imagine you're standing at the bottom of a really tall tree and you're looking all the way up to the top.
Okay.
The angle that your line of sight makes with the ground is the angle of elevation.
Okay. And if you were at the top of the tree looking down at something on the ground, that would be
That's the angle of depression.
depression. Okay, got it.
And so in both of those scenarios, what you're actually doing is creating a right triangle.
Oh, interesting.
Because you've got the height of the object, the distance along the ground, and that like invisible line of sight connecting them.
Yeah. Okay. I can visualize that.
And that's where the trigonometry comes in.
So let's jump into an example, a classic one.
Okay.
So let's say you're out on a sunny day. You see a flagpole casting a shadow.
Yeah.
But the shadow is the exact same length as the flagpole itself.
Okay.
What's the sun's angle of elevation?
So in this case, we actually have a right triangle where the opposite side, the flagpole, and the adjacent side, the shadow, are equal.
Okay.
And if we think back to our trigonometric functions, tangent is opposite over adjacent.
Right.
So in this case, the tangent of the angle is 1,
And the only angle that gives us a tangent of 1 is
45 degrees.
45 degrees. That's so cool.
Yeah.
So just by knowing that the shadow and the object are the same length,
You know the angle.
we know the angle of the sun. That's pretty neat.
It is, yeah, and it's a principle that's been used for like centuries in surveying and architecture.
To calculate heights and distances without actually having to
Exactly.
climb up there with a ruler.
Yeah.
Okay. Are you ready for something a little bit more challenging?
Sure, let's do it.
So let's say we have a tower,
Okay.
and it casts a shadow that's 60 meters longer when the sun's angle of elevation is 30 degrees compared to when it's 45 degrees.
Okay.
How tall is the tower?
So this is where we start to see like the problem-solving power of trig.
Yeah, it sounds tricky.
So we've got two different right triangles formed at these different sun angles.
Okay, I'm following.
And it might seem like we're missing some information, but that difference in shadow lengths is actually the key.
Right.
It allows us to set up an equation using the cotangent, which is adjacent over opposite.
Okay, so we're using these two different shadow lengths and the two different angles to try to find the one constant,
Exactly.
the height of the tower.
The height of the tower, yeah.
Okay.
And so if we work through that equation,
Uh-huh.
what we end up finding is that the tower's height is 30 times the square root of 3 plus 1 meters.
Wow. That sounds
It's more complicated than it sounds.
complicated, but it's all based on those simple relationships.
Yeah.
That's amazing. And I can imagine like ancient mathematicians feeling like they had superpowers or something.
Oh, yeah,
When
definitely.
they figured this out, like you can use math to measure something that seems physically impossible to measure.
Exactly.
Like good luck climbing up that tower with a tape measure.
Exactly. Yeah, and that's really just the beginning.
Right.
There are so many different scenarios where trig helps us figure out information about the world around us. Like, let's say you see a hot air balloon just kind of floating in the sky.
Okay.
You could actually use the angle of elevation from two different points on the ground
Uh-huh.
to figure out not only how high the balloon is,
Wow.
but also how far away it is.
So it's like you're triangulating its position.
Exactly, yeah.
Is that kind of how like GPS works?
That's a great analogy. Yeah, GPS uses a network of satellites
Okay.
and some pretty fancy trigonometry to pinpoint your location.
Okay, I got to know more about that because I
Yeah.
use GPS like all the time,
Yeah.
but never really stopped to think about how it actually works.
Right, so it all starts with these satellites that are orbiting Earth.
Okay.
And each of those satellites is broadcasting a signal.
Uh-huh.
And that signal includes its precise location and the time that the signal was sent.
So there are like these little beacons in space
Yeah, exactly.
just constantly shouting out their coordinates.
Basically, yeah. And then your GPS receiver, whether it's your phone or dedicated device,
Yeah.
picks up those signals from multiple satellites.
Okay.
And by measuring the time it takes for each signal to travel from the satellite to your receiver,
Yeah.
the GPS system can calculate the distance between you and each of those satellites.
So it's using like the speed of light
Yeah.
and the time delay to figure out the distance.
Pretty much. Yeah.
That's clever.
Yeah.
But how does knowing the distance to a few satellites in space
Yeah.
tell me where I am on the ground?
Right, so this is where it gets interesting.
Okay.
If you imagine each of those distances as the radius of a sphere.
Wait, spheres?
Yeah.
I thought we were talking about triangles.
Well, we are, but think about how those spheres intersect the Earth's surface.
Oh, okay.
They create circles, right?
Right, yeah.
And so the GPS system uses those distances and some pretty complicated calculations that involve trigonometry to find the points where those circles intersect.
So basically, my location is the solution to a giant geometry problem
Yeah, you got it.
involving satellites and spheres and circles.
Exactly. And to make it even more accurate.
Oh, there's more.
Yeah. GPS also has to take into account things like the Earth's curvature,
Right?
atmospheric conditions,
Wow.
even relativistic effects because of how fast the satellites are moving.
It's amazing how much math and science goes into something that we just totally take for granted.
It really is, yeah.
Okay, I need a minute to process all that.
Yeah, it's mind-blowing when you think about it.
It is.
And GPS is just one example. Trigonometry pops up in all sorts of places.
But where else?
Like, did you know that it actually plays a big role in music?
Really?
Yeah.
How so?
So, like, the frequencies and waveforms that make up sound can actually be represented and manipulated using trigonometric functions.
So when I'm listening to, like, my favorite song,
Yeah,
there's trigonometry happening
absolutely.
behind the scenes.
Yeah, and even things like computer graphics and animation, like the way that objects move and interact on a screen.
Right?
That's often based on equations that use trig to calculate angles and distances.
So from, like, measuring the height of a tree to creating, like, a whole virtual world,
Yeah.
it seems like trigonometry is everywhere.
It's kind of the hidden language of the universe.
And it's a language that's been spoken for a long time, right?
Yeah. Oh, yeah, for centuries. Like ancient civilizations. They used trigonometry to build these incredible structures.
Yeah, like the pyramids.
Exactly. Yeah, the pyramids, temples.
Long before we had any of the technology that we have today.
It's amazing to think about how they did that.
Yeah, like how did they get everything so precise?
It really makes you realize that those ancient mathematicians were brilliant.
Yeah, they were way ahead of their time.
Definitely. And it's amazing to see how those principles that they figured out are still relevant and being used today.
Yeah, it really is amazing to think about, how something like as basic as triangles
Right.
has such a huge impact.
It is. It's really like a testament to how powerful math is.
Yeah.
We often think about it as like this really abstract thing,
Right.
but it's really all around us.
It's like this hidden language that helps us understand the world.
Exactly. And like with any language,
Yeah.
the more you learn about it, the more you can do with it.
So to everyone listening out there,
Mhm.
next time you're looking up at like a tall building
Yeah.
or the stars or whatever, just remember that there's all this trigonometry going on,
Right.
connecting you to everything.
It's pretty cool.
Yeah, it is.
Maybe it'll inspire you to learn even more.
Yeah, definitely. Always keep learning.
You never know what you'll find.
Well, that's all the time we have for today.
Okay.
Thanks for joining us for this deep dive into trigonometry.
It's been fun.
And until next time, keep exploring and stay curious.